Heteroskedasticity is one of the most important examples in econometrics of a problem that does not necessarily destroy the coefficient estimate, but absolutely can destroy the way we talk about uncertainty. So in this episode, I want to keep the focus very clear. The question is not mainly whether OLS still lands in the right place. The question is whether our standard errors, t-statistics, and confidence intervals are still trustworthy. Start with the definition. Heteroskedasticity means the variance of the error term is not constant across observations. In plain language, some observations are much noisier than others. You can imagine household spending data where richer households have much more variable expenditures, or firm data where large firms have much more volatile outcomes than small firms. The regression line may still describe the conditional mean correctly, but the spread around that line changes with x. That leads to the first reassuring result. Heteroskedasticity by itself does not make OLS biased. As long as the exogeneity condition still holds, the coefficient estimate can still be centered around the truth. R squared also keeps the same interpretation. So if you only learned one thing from this episode, it should be this. Heteroskedasticity is usually not a point estimate problem first. It is an inference problem first. Why does inference fail? Because the usual variance formula for OLS assumes homoskedasticity. Once the error variance changes across observations, that formula is wrong. And if the variance formula is wrong, then the standard errors are wrong. If the standard errors are wrong, the t-statistics and p-values are wrong too. That means you can think a result is highly significant when it is not, or dismiss a result that actually does survive proper inference. The most common repair is to use heteroskedasticity robust standard errors, often called Huber-White or just White standard errors. The idea is to replace the unknown error variances with squared residuals from the regression. That gives us a variance estimator that is consistent even when the form of heteroskedasticity is unknown. Then we take the square root and use that robust standard error in our t-tests and confidence intervals. Notice what robust standard errors do not do. They do not change the coefficients. The estimated slope is exactly the same. What changes is the estimated amount of uncertainty around that slope. In practice, robust standard errors are often larger than conventional ones, though not always. So empirical results that look borderline significant under the usual formula sometimes stop looking convincing once the inference is made robust. Should we always test for heteroskedasticity? The honest answer is that it depends. In a large sample, many researchers simply report robust standard errors by default. That is often a sensible habit. In a smaller sample, testing matters more because conventional standard errors are exact under homoskedasticity, while robust ones rely on large sample approximations. So the smaller the sample, the more carefully we need to think about which inference procedure is actually more reliable. One common testing route uses an auxiliary regression and an LM statistic. The intuition is simple. If the variance of the residuals changes systematically with the regressors, that is evidence against homoskedasticity. The formal mechanics may look a little technical, but the basic logic is very intuitive. Residual scale should not be predictable from X if the error variance is really constant. There is also a second layer to this discussion. Robust standard errors fix inference, but they do not make OLS efficient. If we actually know how the error variance changes across observations, we can do better with weighted least squares. That method gives less weight to noisier observations and more weight to cleaner ones. In the right setting, that can recover the efficiency we lose under ordinary OLS. So the practical rule is straightforward. If you suspect heteroskedasticity and do not know its exact form, use robust standard errors. If you have a credible model for how the variance changes, consider weighted least squares or feasible GLS. And always remember what problem you are solving. Heteroskedasticity usually leaves the coefficient estimate standing, but it can make your stated level of confidence completely misleading. Heteroskedasticity is a good reminder that econometrics is not just about getting a slope coefficient. It is also about getting the uncertainty right. Next, we move into a cluster of further issues around interpretation, functional form, and adjusted R squared that show up constantly in applied work.